Let's work on the 101 final, sample final. Okay. 43.2 centimeters to meters. And so I need the centimeters to disappear, so I need to put centimeters in the denominator so they'll cancel. And I want meters. So I look at my formula page and it says 100 centimeters make 1 meter. So I need to take this times 1 divided by 100, and that's going to be 0.432, if I do it on a calculator, meters. 3.5 cubic yards to cubic feet. So I need the cubic yards to disappear, to cancel out, and I need cubic feet. Now it's on the formula page, but if you don't know it, cubic feet is feet times feet times feet. Cubic yards is yards times yards times yards. And if there's 3 feet make 1 yard, then to cube it, I'd have to take it times itself 3 times, so that would be 27 feet cubed in 1 times 1 times 1 is 1 yard cubed. So there's 27 cubic feet in 1 cubic yard. So I got to take the cubic yards cancel, and I'm going to multiply 3.5 times 27 divided by 1, which is 94.5. These, the cubic yards cancel, and I get cubic feet. This should have been up here. A racer travels 130 feet in 1.5 seconds, and the speed's in miles per hour. So I need to turn the 135 feet into miles. So on your formula page, we need the feet to cancel, and we need miles. And 1 mile is 5,280 feet. So this would cancel. So I got to take this divided by 5,280, because that times 1 is just that, divided by that, and that'll tell me how many miles I'm going. 135 divided by 5280, going 0.02557. 0.02557 miles in 1.5 seconds, but we need hours. So 1.5 seconds. Well, we want the seconds to disappear, so we're going to divide by seconds so that they'll cancel, and multiply by hours, and how many seconds are in an hour. Well, there's 60 seconds in a minute and 60 minutes in an hour, so we got to multiply by 60 times 60, divide by 3600. That's how many seconds are in 1 hour. 60 seconds for every minute and 60 minutes to make an hour. So this cancels. So I got to take 1.5 times 1 divided by this. It's going to be a tiny number. So 1.5 divided by 3600. And it's even got this e minus 4. So that is 4.166 times 10 to the minus 4 hours. So I go this many miles in this many hours. So I got to find the miles per hour. I take this divided by this. So I'm going to do 0.02557 divided by, and to type this in, I would go 4.16666. Enter exponent. On the calculator, it's a double E. Enter exponent. E for enter, E for exponent of 10 of -4. And it's going 61.37 miles per hour. Okay. The area of some glacier is 19 kilometers squared. That's an area. And the average thickness is this. So if it's a glacier and it has an average thickness, so it's got some thickness in it, it's got an area of 19 kilometers squared and a thickness of 0.035 kilometers. So the volume of the ice is the area times the height or the thickness. So that's going to be 19 times 0.035. So the volume of ice is 0.665. So that's 0.665 kilometers times kilometers times kilometers is kilometers cubed. Kilometers squared times another kilometers is kilometers cubed. That's the volume of ice. So if it melts, the water is less than the ice. So we multiply by 5, 6, which is less than 1, which gives us the amount of water. If it was water that froze, it would get bigger. We'd multiply by 6 over 5. So we've got to multiply by the 5 and then divide by 6. So you got to take this times 5 divided by 6. And I get 0.554 kilometers cubed of water. Little less water than there is ice, because ice melts into a smaller volume. Okay. The new surround sound system costs $2,700. After 1 year, the value has dropped to $1,750. Determine all the proper uses of percentage as a fraction. So, as a fraction, we could either do 2,700 divided by 1,750 times 100, and that would be 154%. Okay? So I'm going to write that down over here. I did 2,700 divided by 1,750 times 100 and got 154%. Now I could do this one the other way around. 1,750 divided by 2,700 times 100, and I get 60, so that's 1,750 divided by 2,700 times 100, and I get 64.8%, which is about 65%. So is this correct? The current value, which is this one, is 65% of the original. That's this one, so that is correct. The original is 54% of the current. This is a little over half of this. That's not correct. The current value is 35. Oh, less than, that's not use of a fraction. More than, not fraction. It has to be of. Well, here's an of. Let's see if this is right. The current value is 35% of that. No, this is not 35% of that. So this is not right. Is this an of? Nope, this is an of. The original value is 154% of the current value. That means the current value has to be in the denominator. That's this, and it is 154. So G is correct. All right, to do change, we find the difference in these two. 2,700 minus 1,750, 950. So now we want to do 950 divided by 2,700 times 100 to make it a percent, and we want to do 950 divided by 1,750 times 100 to make it a percent. So 950 divided by 2,700 times 100 makes it 35%-ish, approximately. And 950 divided by 1,750 times 100 is 54%-ish. So now the sentence has to end with more than or less than. Here would be the original value, and here would have to end with the new value. So do either one of these make 65? Nope, it's not even an of. It's got to be a more or less than. 35. So this could be if it's ending with that, the original value. So is the current value is 35% less than the original value. Is that correct? Yes, this is smaller than that, and it's 35% less than. It's this much in percent less than. So C works. D, this is a more than or less than. It's 154, but the change is only 54 or 35. So this one's not going to be one. This is more or less. This is the absolute value. It's 950 more or less than that. That's not a change as a percentage, so it's not this one. And there's no more, mores, or less. So that's an of. This is more or less. And so that's the answers. Five. It says there's 20,000 people. So total number of people go here. It said there were 400 that have the illness. Do have the illness. The total number down here is 400. This box plus this box makes this one. So if I take 400 from this, I get 19,600. that do not have the illness. Those have the illness, those do not have the illness, making the total 20,000. Now, the health test fails to diagnose an illness that is present, so there is an illness, but the test is failing, which means it's giving a test that says, no, don't have the illness when they actually do. Fails 5% of the time. So 0.05 times this goes in there. .05 times 400 is 20. So there's 20 that get a negative test when they have an illness. That's the 5% that it fails. So the rest of them, it gives a correct test. They have the illness and a positive test. So 20 from the 400 total that have the illness is 380 that get a positive test. You've got the disease or illness, and the test says you do. 20 of them get missed. Now, it also predicts correctly 94% of those who do not have the illness. Do not have the illness, a correct test would say a negative test. They don't have the illness. So this has got to be 94% of the total. So 0.94 times 19600, that's 424 of these. So the rest of these get the test. They don't have the illness, but it says, oh, yep, I think you do have it. So I got to take 19,600 minus the ones that are correctly testing, 18,424. That is 1,176. Now, it says we're supposed to fill out the table, show the false positives and the false negatives. This says negative test, but they do have it, so this is a false negative. And this box says they have it, but they don't have it, so this is a false positive. So I've done that. And I probably should figure out these totals. This plus this would be everybody that tests positive. 1176 plus 380 is 556. Oop, what happened? Oh, I didn't get 1176. Knew that wasn't right. I needed another 1 there. 1556. And 20 plus this, so that's 18444. And this plus this should equal 20,000. This plus this should equal 20,000. C, what's the chance of a person receiving a negative test? Negative test, that's these people. All the people that got a negative test. And really not having an illness. Not having an illness, that's those. So that's 18,424. And then times 100 to make it a percent, so divided by 18,444 times 100, and that's 99.9%. Pretty good chance that if they tested negative, that's these guys, that they do not have the illness. 20 of those 18,000s could have the illness, but 18,424 of the 18,444 don't have the illness. Okay? Okay, so now we have 20,000 patients, and 2,400 out of the 4,000 are cured with drug A. So what percentage is that? 2,400 divided by 4,000 times 100 is 60% of the under 30 crowd are cured with A. 43,000 divided by of 6,000, not 43,000, 4,300 times 100 is 71.7%. 660 divided by 6,000 times 100 is 61%. Oh, B is a little bit better for the under 30 crowd. 3,000 divided by 4,000 times 100 is 75%. Oh, drug B is better for the over 30, and it's better for the under 30. Wonder what it is overall. So I didn't make a box for overall, so I read it over here. Overall. So drug A did 6,700. If I add those two together, 6,700 divided by 4,000 plus 6,000, that's 10,000, times 100 to make a percent, and I get 67%. Drug A does 67% overall. Let's see what drug B does overall. So that's 6,660 out of 10,000. 6,660 divided by 10,000 times 100 to make it a percent, and that's 66.6%. Ooh. A's better overall than B, but not better for the under 30 and not better for the over 30. So, what's the numerical evidence that A is better? A has be better overall, 67 to 66.6%. What is the numerical evidence that B is better? B is better for under 30, — 61 to 60. And B is also better for over 30 and older, it's 75% to 71.7%. Calculate the investments, calculating the AP for each, as well as the total investment after 25 years on 9,500. Compounded 6 times a year. Compounded formula. The amount after so many years is the starting amount, 1 plus the rate divided by how many times in a year, times how many times a year, times the number of years. So the starting amount was, this is 9500. The amount after some years is 95001 plus interest rate is 5.3, so that's 0.053 done 6 times a year divided by 6, and so all this to the 6th power, and for 25 years, so 6 times each year for 25 years, so we got to take 6 times 25 for the power. So that comes out to be 9,500 parenthesis 1 plus 0.053 divided by 6, close parenthesis, to the parenthesis 6 times 25, close parenthesis, comes out to be the balance of $35,533.43. The APY is this part minus 1. So I can go up, bring this last one back. Oop. Messed it up. I got to do parenthesis 1 plus 0.053 divided by 6, close parenthesis, to the 6th, says it's 100% plus 5.41% more. That's the APY. Take 1 away from that and make it a percent times 100, and it's 5.418% annual percentage yield. Higher than the APR by a little bit. Compounded continuously. That's the amount after so many years is the starting amount. E to the rate times the number of years. So this would be 9,500 e to the rate of 5.2, so 0.052. Number of years, 25 years. And that will give me the balance. 9,500 e to the power parenthesis 0.052 times 25, close parenthesis, and that's going to come up with 34,858 and 32 cents. So the APY, forget the 25, it's this part, the multiplier, minus 1. So I got to go e to the 0.052, and it's going to be the 5.33%, minus 1, enter, times 100. 5.34%. annual percentage yield. Okay. How much would accumulate in a retirement fund if you made monthly payments, $250, into an account of 4.3% for 30 years? So that's the payment formula. The amount after some years is the amount you make in payments each month times 1 plus the rate divided by the number of months in a year. You got to multiply by that 12 times a year because doing a monthly, so 12 n times the number of years. And that you subtract 1, so this becomes the yield over APR over N. So the amount we'll have after some years will be 250. That's how much we're putting in every month. 1 plus interest rate 0.043 divided by monthly 12. Got to multiply by this 12 times. And for the number of years, 30 years. So put that in parentheses. Minus 1, close the numerator, all over the interest rate, 0.043, compounded 12 times a year, monthly. So, typing that in, 250, parenthesis, 1 plus 0.043 divided by 12 to the parenthesis 12 times 30 years, close the parenthesis, come out of the numerator, or out of the exponent, minus 1, close the numerator, open the numerator, close the numerator, divided by, open the denominator with a parenthesis, 0.043 divided by 12, close the denominator, and get an answer of $183,099.07. If somebody could put $250 away every month for 30 years at 4.3%, they'd have almost 200 grand. Runoff winner, the most first place votes. See, A has 16. B has 14 and 7, 21. And C has 12 and 6, 18. So B is the no, wait a minute. That's the plurality winner. So from here we got to go to runoff. So we do the top two. So we got to do B versus C. So B and C, these 16 would go to B because it beats C. So 16 here. B gets those 14. C wins these 12. C wins this 6. And B wins those 7. Looks like B is the runoff winner. Plurality is B with a 21. Pairwise, we already did B versus C, so we need to do A versus B and A versus C, and that would get all the pairs. A versus B. A gets 16. Oops, sorry on that. B gets the 14. C is not in this AB. B will get those 12. And A gets the 6. And B gets the 7. Looks like B's the winner in this pair. B was the winner in this pair. And so B beats A, B beats C, so B is going to be the pairwise winner. You can do A and C. Whoever wins that, it's not going to matter because B beats A and C. Okay, board account. That's the one that's lengthy. And to be able to see that, I'm going to have to fold this up here a little bit. So you can see the points. Point system. So, first place is 3 points, 2 points, and 1 point. So A gets 16 times 3 plus 14 times second place, 2 points. 14 times 2 plus A gets third place, that's 1 point times 12. 12 times 1 plus 6 times 2 plus 7 times 1. I got to work that out for, that's A's points. B's points are going to be 16 times 2, 14 times 3, 12 times 2, and 6 times 1, and 7 times 3. And C is going to be 16 times 1 plus 14 times 1 plus 12 times 3 plus, this is C, 6 times 3 plus 7 times 2. So this is just a matter of typing these in and getting it. So 16 times 3 plus 14 times 2 plus 12 times 1 plus 6 times 2 plus 7 times 1 is 107. I can do some of this in my head. 32 plus 42 plus 24 plus 6 plus 21 and 125. 16 plus 14 plus 36 plus 18 plus 14 is 98. So B is the board account winner. So B wins all of the elections, looks like. So there's not going to be any dispute on this election. All right. We want to favor A, 5 districts, 5 in each. So that's 25. Got to break them up in 5 each and get favor A. Well, let's see, how many A's are there? 1, 2, 3, 4, 5, 6. So if I'm using A's and want A to win, and it's out of 5, A's going to have to get 3, and to B's 2, and so A would win that one. And if we did it again, 3 to 2, that would use up all of 6 of A's. So all the A's are gone, so the rest can be all B's. So there'd be 5 B's in the 3 more. There's 5 sections. 2 of them A can win, and B will get the rest. So I got to do 3 A's to 2 B's. And so if I do something like this, nope, that won't do it. Let's go here. I got to get 3 A's to 2 B's. So I could go, nope, 3 A's to 2 B's. There, I got 1, 2, 3 A's and 2 B's. Now I got to get 3 A's and 2 B's. I could do this. 3 A's and 2 B's. So A would get this one, A would get this one, and then there's another group of 5. Another group of 5 could go like this, and there's another group of 5 here. This one, this one, this one, this one. So B is going to have the majority of them, but A will at least get 2 of them. Even though there's only 6 out of 25, A could get 2 of the 5. And finally, 4 schools, 30 teachers. And how many students? Let's figure that out. 300 plus 475 plus 150 plus 175. There's 1,100 students. Okay, so to make the classes as small as possible, we'll split this up. All these students divided by the number of teachers to figure out how many students per teacher. So there's going to be 36.6666 students in each class. So this is our standard divisor. So we're going to divide this by that to figure out how many, if there's 36 or almost 37 students in each class, I'm going to divide this by 37, actually by that number, to figure out how many teachers each school gets. So I'm going to do 300 divided by 36.88.18 teachers. 475 divided by 12.95 teachers. 150 divided by 36.6 is 4.09 teachers. And 175 divided by 36.6, 4.77 teachers. So Hamilton says, okay, make sure they get at least 8, get their 12, get their 4, get their 4. See, that's 28 teachers. We've got 2 more teachers. Who gets them? Well, the highest decimals are the 0.95 and the 0.77, so plus 1 here, plus 1 here. So we got 8 teachers going to school A, 12 plus 1, 13 are going to be at B, 4 are going to be at school C, and 5 at school D. 4 plus 1, 5. There's the Hamilton distribution.